Students, our next topic is atomic models. Observation obtained from the experiments mentioned in the previous sections have suggested that Dalton's indivisible atom is composed of subatomic particles carrying positive and negative charges. The major problems before the scientists after the discovery of subatomic particles were to account for the stability of atom, to compare the behavior of elements in terms of both physical and chemical properties, to explain the formation of different kinds of molecules by the combination of different atoms, and to understand the origin and nature of the characteristics of electromagnetic radiation absorbed or emitted by atoms. Different atomic models were proposed to explain the distributions of these charged particles in an atom. Although some of these models were not able to explain the stability of atoms, two of these models, one proposed by J.J. Thomson and the other proposed by Ernst Rutherford. First one is the Thomson model of atom. J.J. Thomson in 1898 proposed that an atom possesses a spherical shape, a radius approximately 10⁻⁻10 meter, in which the positive charge is uniformly distributed. The electrons are embedded into it in such a manner as to give the most stable electrostatic arrangement. Many different names are given to this model, for example, plum pudding, raisin pudding, or watermelon. This model can be visualized as a pudding or watermelon of positive charge with plums or seeds as electrons embedded into it. An important feature of this model is that the mass of the atom is assumed to be uniformly distributed over the atom. Although this model was able to explain the overall neutrality of the atom but was not consistent with the results of the later experiment, Thomson was awarded Nobel Prize for Physics in 1906 for his theoretical and experimental investigations on the conduction of electricity by gases. So some more things related to the experiments. In the later half of the 19th century, different kinds of rays were discovered besides those mentioned earlier. Wilhelm Röntgen in 1895 showed that when electrons strike a material in the cathode ray tubes, produces rays which can cause fluorescence in the fluorescent materials placed outside the cathode ray tubes. Since Röntgen did not know the nature of the radiation, he named them X-rays, and the name is still carried on. It was noticed that X-rays are produced effectively when electrons strike the dense metal anode called targets. These are not deflected by the electric and magnetic fields and have a very high penetrating power through the matter, and this is the reason that these rays are used to study the interior of the objects. So ये बीच में जो मैं अंडरलाइन कर रहा हूँ, ये सारा जैसे कॉम्पिटिटिव में और ऑब्जेक्टिव में या MCQ, इसमें से MCQs पूछे जा सकते हैं, राइट. फॉर एग्जांपल जैसे these are not deflected by the electric and magnetic fields. So these rays are of very short wavelengths, 0.1 nanometer, and possess electromagnetic character. Henry Becquerel, 1852 to 1908, observed that there are certain elements which emit radiation on their own and named this phenomenon as radioactivity, and the elements known as radioactive element. This field was further developed by Marie Curie, Pierre Curie, Rutherford, and Frederick Soddy. It was observed that three kinds of rays, alpha, beta and gamma rays are emitted. Rutherford found that alpha rays consist of high energy particles carrying 2 units of positive charge and 4 units of atomic mass. He concluded that alpha particles are helium nuclei, as when alpha particles combine with 2 electrons yielded helium gas. Beta rays are negatively charged particles similar to electrons. The gamma rays are high energy radiations like X-rays, are of neutral nature and do not consist of particles. So as regards penetrating power, alpha particles are the least, followed by beta rays 100 times than that of alpha particles and gamma rays 1000 times that of alpha particles. तो ये फैक्ट्स भी आ सकते हैं कि which one is more stronger penetrating nature. Rutherford's nuclear model of atom. Rutherford and its students Hans Geiger and Ernest Marsden bombarded very thin gold foil with alpha particles. Rutherford's famous alpha particle scattering experiment is represented in figure 2.5. So this is the experiment. तो ये क्या है, अल्फ़ा बीम ऑफ अल्फ़ा पार्टिकल्स को, ये गोल्ड फॉइल है, ये पूरे का पूरा क्या है, गोल्ड फॉइल है ये. तो उसके बीच में एटम्स का अरेंजमेंट होगा, राइट. सो ये हम देख रहे हैं कि ये जैसे अल्फ़ा पार्टिकल है, ये यहाँ से सीधा चला गया, राइट. सो ये यहाँ से आया और डिफ्लेक्ट कर गया, तो कुछ डिफ्लेक्ट हो रहे हैं, राइट. और ये देखिए, ये यहाँ से सीधा आया और रिफ्लेक्टेड अल्फ़ा पार्टिकल्स ये आ गया, राइट. इसी तरह से इनमें से अबाउट 1 आउट ऑफ 20,000 जो है सीधा आएगा और बैकवर्ड बिल्कुल डिफ्लेक्ट हो जाएगा. सो ये यहाँ से आया और यहीं से वापस हो गया, टकराया भी नहीं है. सो राइट, तो यहाँ से जो वापस हुआ है, क्यों, तो बाद में हम रिज़ल्ट देखेंगे, क्योंकि इसमें पॉजिटिव चार्ज है और अल्फ़ा पार्टिकल्स में पॉजिटिव चार्ज रिपेल कर जाएंगे, इसीलिए ये इसको कोलाइड करने से पहले, टकराने से पहले ही रिपेल हो गया. आता है स्पीड से तो पॉजिटिव रिपल्शन होती है, इसको आके रोक देता है और यहीं से फिर ये रिपेल करता है इसको, राइट. सो ये पार्ट जो है इम्पोर्टेंट है. जैसे अभी हम जैसे एक्सपेरिमेंट इसको पढ़ेंगे तो हम ये चीज़ समझते जाएंगे, और फिर इस एक्सपेरिमेंट को ये एज ए क्वेश्चन भी आता है, इसको पूरा डिस्क्राइब करना है कि कैसे कैसे क्या क्या हमने पहले एक्सपेरिमेंट किया, क्या अपरेटस था, क्या ऑब्जर्वेशंस थी, और फिर क्या हमने उसमें से इन्फ्रेंस, क्या अंदाज़ा लगाया, क्या रिज़ल्ट निकला, राइट. सो लेट्स स्टार्ट दिस. So here the schematic view of Rutherford's scattering experiment. When a beam of alpha particles is shot at a thin gold foil, most of them pass through without much effect. Some, however, are deflected. So a stream of high energy alpha particles from a radioactive source, कौन सा, alpha particles, was directed at a thin foil थिकनेस जिसकी 100 नैनोमीटर है ऑफ गोल्ड मेटल. द थिन गोल्ड फॉयल हैज़ ए सर्कुलर फ्लोरोसेंट जिंक सल्फाइड स्क्रीन अराउंड इट. वेन एवर अल्फा पार्टिकल स्ट्रक द स्क्रीन, ए टाइनी फ्लैश ऑफ लाइट वॉज प्रोड्यूस्ड एट दैट पॉइंट. तो हम ये देखेंगे कि ये लेड प्लेट है, तो इसमें से सोर्स ऑफ अल्फा पार्टिकल से इधर स्ट्राइक करता है. तो जैसे ही गोल्ड फॉयल यहाँ से निकल के आगे स्ट्राइक करेगा, चाहे डिफ्लेक्शन से चाहे स्ट्रेट, तो ये स्पार्क प्रोड्यूस करेगा, राइट. सो टाइनी फ्लैश, जैसे ही यहाँ टकराएगा तो एक फ्लैश निकलेगा ऑफ लाइट वॉज प्रोड्यूस्ड एट दैट पॉइंट. The results of scattering experiment were quite unexpected. According to Thomson model of atom, the mass of each gold atom in the foil should have been spread evenly over the entire atom, and alpha particle had enough energy to pass through such a uniform distribution of mass. It was expected the particles would slow down and change direction only by small angles as they passed through the foil. It was observed that, तो क्या observations थी, Most of the alpha particles pass through the gold foil unreflected. A small fraction of the alpha particles was deflected by small angles. ये small angle से deflect हो गया. A very few alpha particles, 1 in out of 20,000 bounced back. मतलब 20,000 में से एक ही पार्टिकल ऐसा जो कंप्लीट डिफ्लेक्ट हुआ, दैट इज डिफ्लेक्टेड बाय नियरली 180 एंगल. तो यहाँ आया और वापस अगर ये हो गया तो एंगल कितना बना 180 डिग्री. तो ये यहाँ से सीधा अगर ऐसे आया तो वापस अगर ऐसे हो गया तो 180 डिग्री. On the basis of the observations, Rutherford drew the following conclusions regarding the structure of atom. तो ये एक अब conclusion करने जा रहे हैं. पहले हमने observations की थी. So most of the space in the atom is empty as most of the alpha particles pass through the foil undeflected. A very positively charged alpha particles were deflected. A few positively charged alpha particles were deflected. The deflection must be due to the enormous repulsive force, showing that the positive charge of the atom is not spread throughout the atom as Thomson had presumed. The positive charge has to be concentrated in a very small volume that repelled and deflected the positive charge alpha particles. तो कह रहा है कि अगर जैसे थॉमसन ने बोला फैला हुआ है तो तब तो उसको डिफ्लेक्शन नहीं हो पाती. अगर ये डिफ्लेक्शन हो रही है, इट मीन्स द चार्ज positive charge has to be concentrated in a very small volume. Then calculations by Rutherford shows that the volume occupied by the nucleus is negligibly small as compared to that of volume of the atom. The radius of the atom is about 10 to the minus 10 meter, and while that of the nucleus 10 to the minus 15 meter. One can appreciate this difference in size by realizing that if a cricket ball represents a nucleus, then the radius of atom would be about 5 kilometer. Then on the basis of the above observation and conclusions, Rutherford proposed the nuclear model of atom. According to this model, the positive charge and most of the mass of the atom was densely concentrated in an extremely small region. This very small portion of the atom was called nucleus by Rutherford. तो ये मॉडल्स जो अल्टीमेटली जो कंक्लूजन आया और उसका क्या मॉडल हम एक उसको रिप्रेजेंट करेंगे, कैसे एक्सप्लेन करेंगे कि रदरफोर्ड ने क्या जो कंक्लूजन निकाला उसको हम फ्यू पॉइंट्स में कैसे डिस्क्राइब कर सकते हैं. तो एंड देन द न्यूक्लियस इज सराउंडेड बाय इलेक्ट्रॉन्स दैट मूव अराउंड द न्यूक्लियस विद अ वेरी हाई स्पीड इन सर्कुलर पाथ्स कॉल्ड ऑर्बिट्स. Thus Rutherford's model of atom resembles the solar system in which the nucleus plays the role of sun and the electrons that of revolving planets. Electrons and the nucleus are held together by electrostatic force of attraction.